Okay, section 5.2, exercise number 5, part B, asks us to consider these two sets and determine whether or not any of the following relationships hold between these sets, or possibly none of these relationships. So what are these relationships? We're asked to determine whether A is a subset of B, B is a subset of A, maybe the two sets are equal. Maybe the two sets are disjoint. So we're asked to identify if any of these relationships hold or not. So our two sets in question here are sets of integers. A is the set of all integers with the property that they are congruent to 3, mod 4. And B is the set of all integers with the property that 3 divides the integer minus 2. So before we answer these questions, let's maybe get familiar with these sets a little bit. What are some things in A? We won't list them all, but maybe a few of them. We can see maybe a pattern here. The number 3 is in A, because 3 is congruent to 3, modulo 4. To find the next integer congruent to 3 mod 4, we just need to shift up by 3 units. So, I'm sorry, by 4 units. So 7 will also have that property. If I go down by 4 units, I'll also have that property. So negative 1. And we come up with a list. Each number differs by 4. So we're adding 4 or subtracting 4 if we move to the left. B looks a little bit different than maybe what we're used to seeing for descriptions of sets, but that property of 3 dividing y minus 2, notice that's just the definition of y and 2 being congruent, mod 3, right? That's just the definition of y being congruent to 2 modulo 3. Right? If we unravel the definition of congruent mod 3, this would mean 3 divides y minus 2. 3 divides y minus 2. So B does look a lot like A in terms of its description. These are, if we want to try to list some of these elements, 2 is in this set, and then we shift by 3, 5, 8, minus 1, minus 4. Adding 3 each time moves us to the next element in this sort of set mod 3. This allows us to quickly answer some of these questions. Is A a subset of B? No, right? Because we can see just from our little list already that there are things that are in A that are not in B. For example, 7 is in A, but 7 is not in B. So A cannot be a subset of B. Similarly, we get an answer of no here. Again, from our short list down here, we can see that 5, for example, is in B, but 5 is not in A. So B cannot be a subset of A. So definitely no then for equality. That would follow from either of the first two answers being no. Actually, I wrote this last one here wrong. The question wasn't specifically, is the intersection equal to the empty set? And again, we'll get an answer of no here. Our list, I guess we can see the number is -1, but if we want to pick something positive, if I had gone one more term in set B after the number 8 down here, the next number would have been 11. So for example, we could say no, since 11 is in A and 11 is in B. So in particular, we know that 11 is in A intersect B. So that means the intersection could not be the empty set. We have found something in it. Okay.